Okay, fine. So we'll continue with the module 5, that is wind energy conversion. So last class we guys were discussed about the basic component of a wind energy conversion system, and we discussed about the aeroturbine, gearing, coupling, and electrical generator, and how to be connected to utility grid. So today class we are moving with different types of rotors. Of course, as we have discussed, there are two types, horizontal type and vertical type. And in that horizontal type, we have discussed how the connection will be done, because you have a vertical support, but horizontally how the axis will be connected. And other cases, your support and the blades will be kept in vertical position. So that is the major points of rotor system. Based on rotor, as we said, we have a two type, horizontal and vertical. So today class we are discussing based on classification of wind energy conversion system. So first one is horizontal axis and vertical axis. So as I said, these are based on the rotor structure, your horizontal and vertical axis machines. So in that we come to know about the different sizes of windmills are available with their ranges, minimum, moderate and maximum. So up to 2K we call it as a small scale, up to 2 to 100 kilowatt we substitute as a medium size, and 100 kilo to more than that we call it as a large size. So here this is just for utility purpose. You can consider as a residential, small application, remote areas and farmhouses. Medium size, so it is like utilities, apartments or complete area that can be done with this medium size. And large size means you're producing and that will be connected to the grid system where you have a range more than 100 kilowatt, and you're preferring large wind turbines where they're going to generate more than 100 kilovolt of output from the system, and they are used mainly for distribution in your central power grid systems. So next we'll go with different subclasses under a large scale. So there are two quantity you can find. One is single generator, another one is a multiple generator. So depending upon the capacity, your generator will be varied. So if the capacity is high enough and you have a very good source of energy, then instead of one, you could have go for two, three like that. But when you don't have a sufficient amount of wind energy, then one will be in off mode and another one will be working. Means depending upon the capacity, we can add the generators, particularly turbine system. So turbine system can be added 1, 2, 3 like that. Then as per the type of output power, wind aero generators are classified. So there are two quantities. One is completely based on DC output. So means your output is in terms of DC. First is DC generator, direct output, whatever you're getting that will be used for a conversion process. Another one is alternator rectifier. Alternator, it will mislead us. We are going to get the AC output. But as I said, this is based on DC output system. Again, you are using rectifier for the conversion of your AC to DC system. Next, based on AC output. Of course, again, we are having a two parameters. One is variable frequency, variable or constant voltage AC. Another one is constant frequency, variable or constant voltage AC. So in that fixed means you're not going to vary the frequency, just your voltages will be variable. In some cases, you're keeping the frequency constant, say 25 hertz, 30 hertz, 40 hertz like that. But your voltages will be in a variable or constant mode. So that is with respect to AC output. So next type is classified based on rotational speed of your aero turbines. So rotational speed, definitely we know that, right? How the speed will vary based on a wind and blade structure. So let's see what are there. So rotational speed of the aero turbines we're going to classify as constant speed with variable pitch blades. Speed is fixed. So if somebody says based on a pole, 4 pole, 6 pole, 2 pole, you're going to specify the ratings. So it will be 1500, 3600, 1200, is it? So that speed is somewhat constant. So here also you're going for constant speed, but your pitch of the blades will be variable. And this made implies use of a synchronous generator with its constant frequency output. It means you're designing this by using a synchronous generator. Next is nearly constant speed with fixed pitch blades. Nearly constant means you can assume that there is a small variation or existing in the speed system. And if you want to operate this mode, you are going to use induction generator. So induction generator for big to variable speed with a fixed pitch blades. Here speed is almost constant, okay, but the thing you are concentrating on pitch of a blade. Is it variable? Is it constant? If you are going for a variable section, then you are preferring synchronous generator. If you're going for a fixed pitch blade, then you guys are going for induction generator. So next is variable speed with fixed blade. This mode could imply for constant frequency output system. See, in the last case, AC output, we specified constant frequency and variable frequency. Then we can intercouple these two, fixed wave frequency and AC output. So what are all the modes can be operated using a constant frequency? First one is field modulated system, AC-DC to AC link, double output induction generator, AC commutator generator, and other variable speed constant frequency generating system. Means your pitch blades will have this cases of all the 5 parameter. If you have field modulated system, you're using AC-DC, AC link, you're using double output induction generators can be used, and commutator, that is AC commutator generators will be used, and you can prefer other variable speed constant frequency generating systems also. So then wind turbines are also classified as per how the utilization of output is made. Generation is one part, but once you got the output, how you guys are using it. First thing, of course, we are feeding to the system, means home appliances or residential application, you're distributing to the feeders. First point. If not, if you're not distributing, what you're doing, you're going to store the energy. You store it in a batteries, or else you're connected to the grid system. So we know some 1 or 2 points. So let's see which are all the different points can be considered based on a output utilization. First one is battery storage, as I said, you can save the energy. Then another one is direct connection to an electromagnetic energy converter. Means you're going for the conversion of a system directly to electromagnetic energy system. Third one, you can store that in another forms like potential energy, you're saving it. Whenever you want, again, you can use it. So other forms like thermal potential of storage system. Heat which is produced from the system can be stored for the further process. And the last one is interconnection with conventional electric utility grids. Of course, first and last plays a very important role, and most of the application you can find it on first and last point. Next, what are the major advantages and disadvantages of wind energy conversion system? Of course, this is very important question. Definitely, this will be asked in exams, or to know the basic knowledge about the system, we have to go through this. Advantages. So, wind energy. First is what we are buying this for amount? No, it is freely available source. It is one of the clean form of energy, renewable energy, abundantly available energy. Is it? And you don't need to carry, you don't need to transport the system. It is available everywhere, but we need to find out how far the speed or velocity of the system is available. So first one, it is a renewable source of energy. Of course, the first point should be renewable energy. And like all forms of solar energy, wind power system are non-renewable, polluting, so it has a no adverse effect or influence on the environment. So when you say it is a clean energy, then where is the matter of speaking about pollution? So it will be not affecting anything to the system. So there is no carbon dioxide or any inert gases to be leaked, is it? So this is freely available energy which is available in the atmosphere, and that's what say non-pollutant. Then wind energy system avoid fuel provision and transport. Means normally for some of the sources like coal, thermal, is it, you need to take the input sources from one place to the another place, so you have to spend much of the amount for transportation and carrying the system. So but here there is no need of going through this, so you're avoiding that provision of fuel and transport. On a small scale, up to a few kilowatt system is less costly. Means generation wise, because renewable sources, if you're using and if you're constructing any of the converters like electrical systems, then normally we say huge together of amount you have to spend. But here, for a minimum scale, like lesser value 0, 2K, means farmhouses or residential area or isolated area, if you're preferring this wind energy, the cost is somewhat look less. Okay, so less costly. Then on a large scale, cost can be competitive with conventional electricity, and lower cost could be achieved by mass production. So here, if you compare with renewable energy sources also, your wind energy is far better than solar energy, because there is no restriction for wind energy to be generated only in the morning session or night session. So whenever we get a high wind, we can use it. There is no restriction of morning or night. So 24 bar 7, there will be some generation. And when you compare with other systems, retail prices, if you are paying for hydro generated system, thermal generated system, nuclear generated system, the electricity price will be somewhat higher than the normal one. Of course, we can know that there is a huge change in the units consumption in every cases. So minimum 30, then 60, then 80, tariffs will going to differ. So compared to that, conventional sources of energy which are providing the electricity, so this is acting as a competitive segment. So with solar energy, it looks simple and lesser costly as with respect to your solar system. So cost wise also somewhat moderate, clean energy, no need of transportation, and minimum amount, like with a less amount you can go for minimum generation. So these are the major advantages of wind energy system. At the same time, see wherever we find there is advantages, definitely it will also include disadvantages. First one, as I said, 24 bar 7 availability is there, but I cannot assure you when it will be there, because solar energy is somewhat better. Morning that it will exist means exist. If it is 1 or 2 hour, maybe it is cloudy and all. But wind energy, I cannot predict. It depends upon the season. It will be fluctuating, and we cannot assure. Okay, in particular 11 to 12 o'clock, this is the energy. 12 to 1 o'clock, no. Depending upon the situation, it will be very, very fluctuating and dilute in the nature. Second point is, unlike water energy, wind energy needs storage capacity because of its irregularity. So whenever we say generating, we want to give the continuous supply. How you believe that you are going to give the continuous supply? When you have a source constantly in the system. But when you have a trouble in saying that we have a constant source throughout the day, throughout the 24 hours, then I need to have some backup or storage devices, because you are producing the power in irregular way, or as you can say non-linear way. I cannot say it is increasing from 0 to maximum every day. It is increased, decreased, maybe off, then again it is increased. So that's what it needs, a storage capacity devices for wind energy production. Then wind energy system are noisy in operation. A large unit can be heard many kilometers away. Means rotation. So just an example, if you are working any places like huge places, uh, suddenly power goes off, they will switch on the generators. So you can easily identify how the power is coming up, because earlier when the supply was directly on, there is no noise at all. But once you start the DGs, so you start getting a sound. It's like motorbike sounds. The sound will going to come. But that is for small scale we are talking about. But when you compare for a huge and high scale range of power generation, then the noise is very hard. That's what they specified. Many kilometers you can hear that noisy sound. Then wind power system have a relatively high overall weight. Weight will be in terms of tons together, and to turn the turbine it required minimum energy which is sustainably specified, because they involve the construction of a tower, mechanical structure, then of course gearbox is available, hub is there, pitch changer, generator, coupling shaft. So many components, and we are going for a scale which is higher than the small prototypes, so it will be huge weighted. So they say for large weight of 110 kg per kilowatt. So means for a small 1 kilowatt, the weight of the system is 110 kg has been estimated. But do you go for just kilowatt power generation? Kilowatt power, okay, 110 kg is somewhat fine. But if you're going for 20, 30, 40, you just multiply the value with 110. So you'll understand how much it is. That's what I say, for large scale, it will be in tons together. Then large area needed Typically, propellers of 1 to 3 meter in diameter, delivery power in 30 to 300 watt range. So propellers means the blades which are rotating. So that will be carried from one point to another point. So we have to transport that from one place to another place. And for installing the system, we need a larger area. And if the dia of a propeller is 1 to 3, then you can achieve the power, means you can get the delivered power as 30 to 300 watt range. So any doubts in the advantage and disadvantage? Once again, you go through this, guys. I will just give 1 minute time to read the slide. Go through it once and mark it as a very important question. So almost 5 points are there. Almost one-to-one, back-to-back connection is there. Renewable, clean energy, no pollution, no transportation. Is it? For mass production also, it is a good, healthy, competitive electricity bill can be get it from your wind energy. Okay, so these are the disadvantages. Disadvantages: nature of a wind, storage capacity, and we require a large and high weighted system for installing, because it include that. Then propellers to implement of 1 to 3 diameter itself for the generation of 30 to 300 watt, we need to get large area for implementation. Okay, so the next is wind energy collectors. Solar collectors, we know that, is it? Wind energy collectors, we need to think. We don't have any panels, but we have a blade system. Is it hub system? So they're responsible for this. Let's go with one by one. A windmill is a machine for wind energy conversion. So from olden days, we people are calling wind energy generation mills as windmill. This is a shortcut. So windmill is a machine which is going for the wind energy conversion. Means wind energy to mechanical energy, then mechanical energy to electrical energy. Means your air mass, whatever is available, and that plays a very important role for the conversion of a system. Second point, a wind turbine converts kinetic energy of the wind motion to mechanical energy transmitted by the shaft, because your generator, aero generator is connected to the shaft of a system. So we need to get a mechanical input. So from where I will get the kinetic energy of the wind? Wind means air, and it's going to create the motion of a mechanical energy, and which is transmitted to the shaft of a system. Then our generator next function is conversion of mechanical energy to electrical energy, so that finally you are generating the electricity. And the term windmill, which is originally implied a mill for grinding grain, means earlier days the people are using this wind energy for the applications of household or farming application. That's what they say. Initially, it was implied to mill a grinding grains which are used in our farming houses. Now we are eating it, but farmers, they're providing or producing it, right? So they're using this windmill for grinding the grain. An obvious misnomer when applied to the electrical power generation, because earlier there was a no thought that you people are going for generation of electricity. Just for household and minimum application, those people are using it, and the term is still widely used. However, means still people are saying it as windmill only. Now we will also say directly, right, about windmill. We will not say wind energy conversion system, we say windmill. Aero generators avoids difficulty. Only in this last century how windmills have been used to generate electric power. Means from last century, means from 2020, the people have started on working for production of electrical energy, and that is tied up with a grid system. Earlier and all, just for farming purpose or a small scale of house purpose, people are using this. But huge generation and contributing to the electricity demand, so that is done from past decade of a system. And wind aero generator or wind turbine generates of wind energy conversion systems are classified. So this is already done. Again, repeatedly, they are going to say about two types, horizontal and vertical, because we are moving with design, construction, how it looks. So because every time I'm saying horizontal axis, vertical axis, how it will be, definitely we have to see that. Then horizontal axis wind machines are further. Again, it was subclassified as a single blade, multi-blade, and bicycle multi-blade types. So these are the three major types. You can find it here. So one is single blade. So you're going with classified as single blade, multi-blade, and bicycle blade. What is that? Bicycle blade. So you have a sail, wind, multi-blade, or example of horizontal axis wind machine. Savinus and Darius rotor are example of vertical axis. Means they will ask you, give me some example of horizontally existing system, vertically existing system. So you can say sail, wind, multi-blade companies there. So they are producing the horizontal axis and as well as the Savinus and the Darius rotor. So this example of vertical axis machine. Then vertical axis windmill or machine is again subdivided because horizontally we got two types. Again in vertical, again it is divided into two types. One is Savinius or S type of rotor. Another one is Darius type of rotor mill. So here they segregated these types based on the speed of a system. Wind velocity, how it is existing. For low wind velocity, the people are using S-type rotor, that is 7 years type rotor. For a high velocity, the place where you have a high wind velocity, so you can go with the rotor type of Darius. So which are based on the working of a speed of a machine for operation. Means depending upon the capacity, we can choose low or high type of rotor system. In vertical, as I said, there are two types. One is S-type rotor, another one is Darius type of a rotor. And Darius type of rotor is used whenever we have a high velocity of wind. Okay. And in case of horizontal, sail, wind, and multi-blade are the examples. So in horizontal also we got two types, and vertical also we got two types. So now we start observing the pictures, how the rotor looks. So can you see the Savinus rotor? Savinus rotor, we have only two blades. So you can find it, the mechanical, sorry. Wait a minute. So we have a vertical support where the blades has been connected. So it will just look like horizontal 180-degree curve, is it? But in Darius, you can observe it is look like completed. If it start rotating continuously, you cannot find is it closed or unclosed. So you can observe the picture here, how wind power works. So some example with picture you can observe here, gearbox. So gearbox, lower hub of a system. So blades, rotor blades, and wire. Then upper hub. Hub means top and bottom. You need to give the support for the blades, right? So top and bottom, and below that we have a complete big gearbox system, and that output is connected to generator. Hub, gearbox, and generator. Below that we have a mechanical support. So this is the basic construction. So you can have two, you can have three. So in hub, almost all Darius hub rotor, we are having three blades. Next, we'll go for horizontal axial machine. So the common wind turbine with a horizontal axis is simple in principle, but the design of the complete system, especially a large one that will produce electric power economically, but it is complex. Means designing and all, because we expect simple design, simple construction, so that everyone can understand, everyone can easily detect the problem. But commonly, the wind turbines of horizontal axis, principle wise, design wise, it's fine, but implementation somewhere it looks like a complex. Then the rotor, transmission, generator, and tower should be efficient as possible. So these are all combined, right? So if they are working in a proper way from 1 to 1, then only I can say I'm getting a 100% output. If transmission line is not working properly, if the generator is not operating, if the rotor is not rotating, then where I can say this is efficiently working. If any one part is damaged, if it is affect the whole system, then we say the overall system is not working at all. Okay, and some of the horizontal axis type wind machines are, you can see first one, horizontal axis using two aerodynamic blades. Means based on the blades which you set up with that hub system, we're going to tell you what type it is. So first one is what? Horizontal axis using two aerodynamic blades. Two. So number says you're using two aerodynamic blades. So first one, Savinos you can consider. So in this type of a design, the rotor drives a generator through a step-up gearbox. So below that we have seen there is a gearbox, is it? So this is the gearbox. So this is the gearbox. This is below that we have again a mechanical support. We have a lower hub, upper hub, and a guide valve and a rotor blade. So rotor blade is three types. Okay. Next is the components are mounted on a blade plate which is attached on a pintle at the top of the tower. Means their mechanical supports how the connection has been done by using these blades. Then the rotor blades are continuously flexed by unsteady aerodynamic. So you can see the characteristics of the blade system, how they are working on it. So flexed by unsteady aerodynamic, gravitational and inertial loads when the machine is in operation. Means your rotor blades are continuously observing these all cases. What is the unsteady aerodynamic condition? What is the gravitational force existing? Inertia of the load, all will be considered. Then, if the blades are made up of metal, flexing reduces their fatigue life with the rotor and tower is also subjected to above loads, which may cause serious damages. It's like based on a capacity. So people using metal blades, of course, weight wise, it is still more heavier as compared to the other material which are used for making the blades. Okay, and it will going to reduce the fatigue of the fatigue in the sense lifetime of the system. And the rotor tower can also be subject to the load because it is not just a prototype to show this will happen, this will happen. No, you're going with a live condition, you're connecting it and you're finding the system, what changes are happening. Is it required to have a sources, or else if I want to have a gearbox, any change in gearbox value or generator value, all these things you have to consider. And if the vibrational modes of the rotor happen to coincide with one of the natural mode of the vibration of the tower, the system may shake itself to pieces. So here, if it is run out of the range, because let us assume this is the blade. So you can see this is a hub of a system and rotor. We have a wind netting the system and windmill support. You can say head and the tail, wave and supporting structure. So you are designed for the system mechanically to hold for the given speed. Some speed is you are fixed, okay, for this speed, nothing will happen, nothing will healthy condition. If they are going more than that or continuously running the system for a longer period, then the vibration will definitely happen. So the vibration mode of the rotor will happen and coincide with one of the natural mode. Where there is a variation of the tower value, system may shake by itself because of a high speed. Means vibrant, it is not able to possible to hold it. Two cases will happen. If it is very minimum also, system will not work. If it is very high also, system will not work. So it will start giving the shaking or vibration of effect. Because of high cost of the blade, rotor with more than two blades are not recommended. So when you're going for a construction of a high cost system, so what happens? The blade rotor with more than two blades, rotor kind if you're using, so it is restricted to only two blades. So more than that will not be recommended. So because of the cost of the blades cost only larger because size wise, length wise, diameter wise, everything should be calculated and it is too huge weight. So that's what high cost of a blade rotor with more than two blades. So more than two blades will not be recommended by the system. Then horizontal axis propeller type using a single blade. Single blade, how it will work? Two blade, fine. Single blade. Two blade means somewhere we say balanced. But single blade, how the effect will be taken care, how it is going to operate. So here in this arrangement, a long blade is mounted on the grid rig. So your grid long blades which is connected to the grid. Then induction generator and gearbox also shown. If extremely long blades, if say if we are expecting the minimum, no fine, like there is no problem at all. But it is more than the limited, or if the size or the capacity is still more, then we have to think about what is the construction, how to balance the blade system. So in that case, it's variable cases, we are preferring induction generator and gearbox also. So we have discussed about a diameter 2 meter to 3 meter. So this is the output. But if the blade length is more than 60 meter, which are mounted on the rigid hub, large blade root bending moment may occur due to the tower shadow, gravity, and sudden shift in the wind direction. Means if it is very, very lengthy, so balancing of a system is very tough enough. So it can be a problem due to the gravity, or it may falls due to the high efficient input throwing on the system. So you should be careful about the system more than the diameter of 60 meter. Then to reduce the rotor cost, use of low cost counterweight is recommended, which balances the long weight centrifugally. Means cost wise, as we say, small scale cost is somewhat acceptable because 10,000, 15,000 it looks small for the installer. But if I say 1 crore, 2 crore, then they'll start thinking, should I go for this installation? But in this case, to reduce the cost, rotor cost, so what and all we have to do? Use of lower cost counterweight is recommended. Means as much as possible to reduce the weight, because it was given as per calculation 1 kilowatt of power. You are paying some 110 rupees. Just an assumption you made, 110 rupees. So the weight is 110 kg. So 110 kg is somewhat minimum for 1 kilo. So if I say 5 kilo, so multiplied by 5. So what happening? The size is becoming increasing. So they will restrict that. Okay, this is the minimum value, minimum weight of the windmill. Within that itself you need to achieve. Then it is very much necessary for us to balance and centrifugal the system. So advantages of blade rotor, you can see the picture, vertical structure. You can call that as a just a minute. Yeah. So see here, this is the steel shell tower welded, and we have a pitch. I have